So the first easy question is, what is a trap? Now, a trap is not what you saw on the first page, which is that kind of, that device that you use to get your mouse in the house or so, or wherever you don't want in the house. That's not what we're talking about. In this context, we're referring to the rocks. We're referring to the rocks taking on different geometries or different configurations in a way that if a fluid such as oil or gas finds its way into that arrangement, it will not escape. So a trap is any configuration of rocks that has the capacity to keep hydrocarbon in place for some good, length of time until we, the geologists, go find them, or the geophysicists will go find, or the engineers will go find that hydrocarbon. Another thing to keep in mind is trapping may also be as a result of, some natural, creation of boundaries due to variations in properties. Pressure is, for example, an example, and then rock facies or rock quality. For those of us who are familiar with carbonates, of course, you think of, it's not necessarily structural, it's more of changes in the property of the rock, in the 3D sense of things. And even in classic settings, you might have stratigraphic pinch outs or facies or lateral facies change. I mean, those are things that can actually lead to, creation of a trapping configuration. Another very important thing is that rocks, do undergo alterations. I mentioned that earlier on. So it's not a simple, one cycle deformation or one cycle, alteration. Sometimes in the first case, you have some folding. In some other case, you have an additional faulting. And some other case, some conditions will change. And that same original trap might actually undergo some kind of change from one time to the other. And that in the long run will affect, the outcome, what we see in the long term. So is the trap working? When we ask this question, what comes to mind is, thinking about everything that makes this trap a success or not. So this is just to show you a simple example of, some gentle trusted anticline in this case. I'm familiar with things like this. So yeah, I know it's a trusted anticline. Some people might argue it's some detachment fault, but the key thing is that this is an example of what can keep a trap, what can create a trap. In some other scenarios, you might have some kind of normal faulting that may create a combination of, an arrangement that will be able to house hydrocarbon. We'll look at, one or two examples as we progress. Either in a hanging wall or footwall, things might actually be preserved or kept in place. So when we say is the trap working, the questions we have in mind, because a number of questions we have in mind, a number of things we have in mind. We think about structural spills, we think about juxtaposition leaks, we think about, the rock themselves, the rocks around that particular trap, the capillary and the mechanical seal capacities of these rocks. We think about if it's a fault plane, you're asking yourself, what are the materials in that, that zone, that fault zone, right? What kind of materials do you have in there separating one fault block from the other fault block? You're also asking yourself, what is the through? How much of offset do I have, right? From the hanging wall to the footwall, whether in normal or reverse systems or reverse faulting systems, you also want to know how much of through do I have? And then another very important thing is, what is the history of this? If you're able to answer all those questions about materials, the capillary and mechanical seals, you're also you're just going to ask the question of, what happened to this rock initially and what happened thereafter? So that's where the history becomes a very important piece of the story. So that's what this question is: a trap working? That's what it is all about.